All right, so for homework, I asked you to solve 2 trig questions, and then I asked you to factor 1 trig expression. All right, so we'll go through those. If you have any questions, we'll address those, and then today we're just going to kind of continue with this. We'll do some more practice. There's a few more types of examples I want you to see. And yeah, we'll take our time with this because this is a little different. I don't want to spend too much time with this just because we do have some other trig stuff to talk about. But I want to make sure you guys are okay with just the basic solving the trig equations. All right, so our first one, we have 4 sine squared of x minus 3 equals 0. Okay, thanks for letting me know, Cindy. So again, we work from the outside in. We do everything that we can to isolate the x, right? We're looking to solve. That's what we do when we solve. So the first thing we can do is add 3 to both sides. And then I can divide by 4. So I have sine squared of x equals 3/4. So here, we can't do anything with the sign yet because we still have the squared, right? So remember, I can rewrite. If you get confused by sine squared of x, you can rewrite it as sine of x squared. Okay? So the sign, to get rid of that squared, right? We said yesterday we have to take the square root, and we have to make sure that that plus or minus is in front. So right now I am looking at the sine of x is equal to positive, negative. I have the square root, and again, when we square root a fraction, we can distribute that square root to both the numerator and denominator. The square root of 3, we don't, that's not a nice number, so we're going to leave it the square root of 3. And then the square root of 4 is 2. So I have that the sine of x is equal to positive or negative root 3 over 2. Okay, so once we get to this position, I can see where there's some difficulty, because normally what I taught you guys to do originally was to do the inverse sine. The problem with that is if you are using a calculator, it will not, well, I mean, you can find the answer in radians, but it won't give you the answer in radians in terms of pi. Okay, you can find the angle that it's equal to in degrees, but if they're looking for the answer in radians, all right, we're going to have to go to the unit circle. So there's 2 things to remember with the unit circle. Well, kind of one thing, but where's my picture? I had it yesterday. I think I got rid of it. Let me see if I can find another one. Yeah, okay. So right, with the unit circle, we have 2 coordinates, our x's and our y's. So the sign refers to the y coordinate. So again, I'm looking for y coordinates in my unit circle where I'm either equal to positive root 3 over 2 or negative root 3 over 2. So normally, if it was just positive root 3 over 2, right? Remember, we have 2 possible solutions. If it's negative root 3 over 2, again, we have 2 possible solutions. With both a positive and negative, we may have up to 4 solutions. All right, so let's take a look and see what we get. Let me just double check my answers. Yeah, okay. All right, so looking at our unit circle, I'm looking for where is my y coordinate, root 3 over 2 or negative root 3 over 2. So going along the first quadrant, okay, I have a root 3 over 2 here, but that's in the x coordinate. So that would be for cosine, so that's not going to help me. Continuing along, I see a root 3 over 2 in the y coordinate. So that tells me that my x, my angle, is going to be pi over 3. All right, so that's one of my answers, pi over 3. Now remember, we have to take into consideration that it's periodic, right? So I'm going to add to that 2 pi n. So that's one of my answers in the general form. Let's go back to the unit circle to see if there's any other solutions. So again, I'm going around the circle. I'm looking for root 3 over 2. Well, look at that right here. So at 2 pi over 3, I also have the cosine of 2, I'm sorry, the sine of 2 pi over 3 is root 3 over 2. So I have a second answer. And again, I'm going to add 2 pi n. Look a little nicer. Okay, so if I was only worried about the positive root 3 over 2, then I'd be done. But we have to take into consideration the negative aspects too. So in theory, I should have 2 more solutions. So now I'm looking for negative root 3 over 2 in the y coordinate, which, if you've noticed, as you get more comfortable with the unit circle, you'll notice some similarities, some symmetries, right? So here, both of our answers were the closer to the y-axis, we can say, right? This point over here and this point over here, and they are symmetrical on that side. Well, it also goes that it's symmetrical from top to bottom, right? So here I have 1/2 root 3 over 2. Down here I have 1/2 root 3 over 2. So you can kind of use that symmetry as a quick shortcut instead of looking around each point and looking for root 3 over 2. So down here, I can see I have 2 other instances where I have negative root 3 over 2 at 4 pi over 3 and at 5 pi over 3. And again, for each of these, I'm going to add 2 pi n. So for our first problem, we have 4 possible solutions in general form. All right. That's a 5. Okay, any questions about that? All right, so again, the reason we had so many solutions is because of the sine squared, which gave us the positive and negative aspect. All right, so just be careful with that. If it's just sine, if this was just 4 sine whatever, then you're only worried about 2 possible solutions. All right, let's take a look at this second problem. All right, so we got 2 cosine squared x equals cosine x. So this one was similar to the one we did in class yesterday, where we want to get everything on one side. Give me 1 second, sorry guys. All right, so I subtract cosine from both sides, so I get 2 cosine squared x minus cosine x equals 0. Right? Sometimes that equals 0 will help us, because then we can use some of our basic algebra properties. So I can't combine these because this is a cosine squared and that's a cosine, but they do share one cosine. So I factor out a cosine x. When I take out a cosine x from here, I'm left with 2 cosine. The minus comes along. When I take out a cosine from cosine, I'm left with 1. So this is our multiplicative property of 0. So I can split this, and I can say that cosine of x is equal to 0, and that 2 cosine x minus 1 is also equal to 0. So this one's straightforward, right? You're looking, where is my cosine 0? So again, for now, we'll reference the unit circle. Cosine is the y. No, cosine is the x. So we have at pi over 2 and at 3 pi over 2. So just from this, I get the pi over 2, and then, like we do normally, plus 2 pi n. And then I have 3 pi over 2 plus 2 pi n. So those are my solutions from this part. Now with this part, I do my algebra part, and I get that cosine of x equals 1/2. So now I go back to the unit circle, and I look, where does my x value equal positive 1/2? Well, obviously it's not going to be on the left side, because there all my x values are negative. So here at pi over 3, I have the x is 1/2. And then the symmetry tells me if I go down, 5 pi over 3. So I have pi over 3 plus 2 pi n. And then 5 pi over 3 plus 2 pi n. So again, we have 4 solutions, but it's a little different this time because of the way we split it up. Right, so for now, it's a little bit of a pain in the ass. You have to go reference the unit circle and kind of do a reverse, right? You have to look for the coordinate, and then that tells you what your angle is. All right. We won't have to do that for too much longer, though, but for now, that's how it's going to be. All right, any questions about the solving aspects before we move on to the factoring?
No, I understand now.
Okay, you get a little better? You got my email this morning?
Yeah, I did. I responded. Thank you.
Okay, no problem.
I don't understand this
At all?
What is it? Confused me.
Okay, so after we go through this, we'll go over some more examples, and we'll try to work it out. Okay. So let's just do the number 3 real quick, where we had to factor. Let me make sure I get that right. So I asked you to factor 2 sine squared x minus 3 sine x plus 1. So with this, okay, again, if the trig part confuses you, okay, replace it for now, right? I like to use y, but you can use anything you want. Okay, you can use, I wouldn't use x just because x is already there, but you can use any other letter that you'd like. So let's say that sine of x is b, right? So I'm going to substitute anywhere I see a sine of x, I'm going to substitute it with b. So this would become 2b squared minus 3b plus 1. So now I want to split this up, right? And there's a few ways to do the factoring part. It depends on however you learned it way back in algebra or 8th grade or whenever the last time you did basic factoring was. But we know that the first 2 numbers in our 2 binomials multiply to this, right? So we only have 2 options for 2. So one's going to be 2b and one's going to be 1b. And I only have 2 options for 1. Actually, I only have 1 option for 1 and 1. Now, we have to choose which one's going to be positive, negative. Are they both going to be the same? So because this is positive, that tells me either these two both have to be positive or they both have to be negative. Because the middle, where we add them up, is negative, they're both going to be negative there. So now that we have it factored, I can go back and I can resubstitute in sign. So 2 sine squared x minus 3 sine x plus 1 factors out to 2 sine x minus 1 times sine x minus 1. And you can always double check by foiling, by going in the other direction. All right, if I multiply those two, I get 2 sine squared minus 2 sine, oh, that's real sloppy, minus 2 sine minus sine plus 1. And when I combine these, I get my original equation.
Mr. Murray,
What's up?
I made a dumb mistake on the homework. For some reason, I
happened?
thought the middle number was like -2. So
That number there?
yeah, I made a mistake. It was like I don't
Okay.
know. I guess like you just made a mistake. So
You just
yeah.
copied it down wrong. It happens.
Yeah, I
So
followed
you
instructions.
probably struggled finding a factorization because that's pretty difficult. So yeah, it happens. So yeah, just be careful. All right, I'm not gonna penalize you too much for it. So just in the future, be careful. Okay.
Thank you.
Any other questions? All right. So let's take a look at some other things here now. All right, we don't have much time, so I'll get through a couple of them. See how many we can get through. Okay. Okay, so we are going to go over a basic solving equation, but I'm going to add a little bit extra, which actually is going to help us. So let us I don't want to jump to that right away. Sorry, guys. Okay, so here we have a similar situation. Find the solutions of here. We'll deal with this quadratic just because I want to show you another quadratic. But now they give us a stipulation. Our solutions are going to be on the interval from 0 to 2 pi. So what this tells us is we're only worried about one rotation. So I don't have to worry about adding one of these at the end. Okay, so when they give you a window of your solutions, you're just looking on the unit circle, right? From 0 to 2 pi. That's a whole full rotation. So once you find your answer, that's it. That's your answer. I mean, you may have more than one answer like we have, but you don't have to worry about adding the extra part for the general solution. All right, so here we have 2 cosine squared x plus cosine x minus 1. So I'm going to split this up. Well, again, 2 cosine only has 2 factors, 2 and 1. So I'm going to have a 2 cosine x over here and a cosine x over there. You can have them switched. It doesn't matter the order, right? Just as long as one of them has a 2 in front of it and one of them has a 1 in front of it. Let me just see if I can make this a little clearer. This is a little out of focus. I think that's a little better. That's exactly the same. Never mind. All right, and then we have the 1 there again. So again, we're going to have 1 and 1. So now we have to figure out, because this is negative, one of them has to be positive, one of them has to be negative. So here I have a positive. So whenever I do my multiplication for my foiling, I want to make sure that the larger part, the larger middle part, is positive. So that tells me I'm going to put a plus over here so that I have a positive 2 cosine x minus cosine x. So that's going to get me that positive 1 cosine there. Now that I have 2 separate ones being multiplied equal to 0, we can separate them. Right, and we go through our normal algebra steps. So I add 1 divided by 2. I have cosine of x equals 1/2. I subtract 1. Cosine of x equals -1. Okay, so again, unfortunately right now, what we have to do is we have to reference our unit circle. Right, so again, cosine is the x value, the x coordinate. So first I'm looking, where is my x coordinate equal to positive 1/2? So my x coordinate is positive 1/2 here at pi over 3. And then also down here again at 5 pi over 3. But now, like I said before, I don't have to add anything extra because these are the only 2 values in between 0 and 2 pi, right, on one full circle. So I'm not worried about doing any other rotations and finding the periodic answers, right? That's it for that. Now this one, cosine of x equals -1, the only spot where the x value is -1 is over here at 180 degrees or at pi. So for this answer, I only have one solution, and that's going to be x equals pi. And then you can always go back and write, well, you should always go back and check and plug in your answers. But we know that they're going to work. Right, so if I plug in pi over 3, here I get 1/2. Right, so for all of these, I get 1/2. So 1/2 squared is 1/4, plus another 1/2 minus 1. That does get us 0, right? And then pi gets us -1. So 2 minus 1 minus 1, that gets us 0. And so both of those work. All right. Do we feel any better about this, or did I not really help anybody? Or what's the deal? Because if we're still struggling a little bit, we'll take some more time tomorrow when we, and go over some more examples.
I understood this one so much more clear
Okay. Yeah, once you start seeing it and you start getting used to how it acts, it's a little better.
Yeah, I agree with Barbara.
Okay. So then tomorrow we'll start. We'll still stick with solving trig equations, but we'll take it up a notch. And then we'll see where we are from there. All right, guys. So yeah. Yeah, that'll be it. All right. Have a good day, and I'll see everybody tomorrow.
Bye, Mr. Murray.